All right, welcome back. I am Chris Lucian with Deadly Apps, and I am working on Skull Survivor. Um, and today we're gonna just start creating some unit tests. So we're gonna kind of start at the higher level of the testing pyramid. We're gonna create an integration test, and what we're trying to solve is this idea that enemies, when they get too far away, they actually, right now in Skull Survivor, because enemies keep getting health over time and things like that, they're actually becoming too powerful for people to kill. And the spawner stops spawning at a certain level to maintain frame rate. So, what we want to do is we want to nav mesh warp our characters to a location around the player. So that's kind of a little bit of what we're going to do, and we're going to set up kind of the target for that. And so the first thing we're going to do is we're going to make an editor test. And we're going to use that editor test to prove that the integration with the nav mesh system is working. So that's why it's an integration test. These tests are more fragile. We want to make them like as simple as possible. So we're going to just kind of go from there. So first, to get started, I'll kind of show you. Right now we got a bunch of unit tests. If I run them all, they're all passing. We're going to kind of create a couple more test files after this. If I go into play mode, we got this one test, and I'll just show you in the source code, nothing's happening in here. I expect this to pass, and so I'm just going to close others here. And I just had created kind of a class already with some stuff in it, and we're going to just take a look at that. So these tests are pretty slow, but you can see it creates a brand new scene. It does all the setup in it, and then it does its thing. And yeah, so we're going to just kind of work from there. So kind of created this just ahead of time just to save a little bit of time. Other thing is I'll just show you the problem right now. So I'll go into Skull Survivor. Audio might need to be muted, so sorry if it blasts at you. But yeah, here we go. So right now, if I dock the play mode down here, and then I focus on the player, you'll kind of see, the red lines are the enemies, right? And so if I can keep upgrading my sprint, I can start out running them, and we eventually it'll just stop spawning after we hit a certain number of enemies, and then they just keep chasing. So those red lines up here at the top left corner, those lines will just get longer and longer and longer, and enemies will just keep, will kind of stop spawning, and they'll just chase me forever. So what we want to do is we want to make sure that those lines kind of stay short. We want to teleport them to the player using the nav mesh warp on them, so that we keep getting kind of assaulted from all sides no matter what, even if the enemies kind of fall behind. So that's the goal. We're going to get into that right now. All right, so number one is we need a player. So we're going to have an arrange act assert. Just for those of you who don't write unit tests a lot. So basically we're going to have, a player, and then we're going to have an enemy, and then we're going to kind of have this like enemy health, maybe just like warp, add warp to target when exceed distance component the enemy, and target the player, right? And so then basically we're going to say, and we're going to put them far away from each other. Move player and enemy far away from each other. And then we're going to wait a frame. So we're going to just say wait a frame. And then we're going to assert that we move the enemy near the player again, right? So this wait, so this all the unity tests, right? So we have the difference between unit tests and unity tests, and so unity tests run as coroutines, and so we're gonna do we're gonna kind of just do all these things. So first thing is var player equals new game object, and then we're gonna have var enemy equals new enemy, sorry, game object, right? We are assuming that there's a nav mesh on there, but we're not going to worry about it until we see it start failing. So we're going to say enemy dot add component, and we're going to add a warp to target when exceeds distance, right? This is the class that doesn't exist yet, so we're going to go ahead and create that in a second. And then yeah, and we're gonna say var warp equals that, and we're going to then target that player. Warp dot target equals player. We're gonna probably make it at their transform, maybe. I don't know if it should be the transform or not, but we're gonna kind of stay away from the game object in this case. And move player to enemy when they're far away from each other. So we're gonna just say player dot transform dot position equals new. And Skull Survivor is on a 2D plane. You could obviously do this in 3D as well, but I'm gonna basically do a vector 3, but I'm gonna keep the y-axis as 0. And actually, for the player, we're just gonna keep it all 0 anyway. And then finally, we are also going to have enemy, and we're going to move him 1,000 away. Position equals new vector 3, and we're going to make them 1,000 units away on the x-axis, because I don't really care too much. Again, we're going to cover variations in the unit test level. We just want to make sure that this component integrates properly and does the warp, which is specifically interesting to us. So with all of that, we are going to basically, we can't quite wait for an end of a frame, but we need to wait for the frame to happen. So what we're going to do is we're going to just kind of count how many frames we've gone, and we're going to just keep waiting until, so time dot frame count is the frames that are inside that every time update cycle runs in Unity, but that's different from a frame like in your frames per second counter. So it's pretty confusing, but so what we're going to do is we're going to say var old frames equals time dot frame count. And you might do this a different way, but this is just kind of like an easy way to illustrate it, I guess. And we're going to just say time dot frame count minus old frames equals 0. So while there's no difference between the frames, we're going to just keep looping yield return new wait for end of frame. And so what this will do is it'll just wait until one update loop happens, or many could happen, but it's not going to matter in our case. So that's kind of the act, and we can kind of extract this later, but I'm just kind of keeping it as obvious as possible. Finally, we're going to create our assertion, right? So we're going to say var distance after update loop equals vector3 dot get dot distance, and we're going to just say player dot transform dot position enemy dot transform dot position, and we want to assert. Oh, we might need to bring in the assertion library. Already did. And we're going to say dot less or equal to uh, 50, right? So we basically, I'm thinking the distance of 50 might be the default on the component. We'll make that a serializable field so we can interact with it. But for the purposes of our integration test, we can just use the defaults and we can test around the defaults and be fine. So, oh, sorry, less or equal, we need, less or equal, oh, that's comparing two values, oh, yeah, sorry, 50 and, R1, R2, and then message params. So, in here, we're gonna just say distance after the if loop. So, there might be something wrong with it, but, so yeah, basically what we've got is, if our code doesn't work based on our act, then we would be 1,000 units away. This value would be 1,000 and our test would fail. If our code works properly and a update frame goes by, then we would see the teleportation happen. And so we'll probably need some nav mesh stuff in here, because right now you'll notice that there's nothing around nav meshes, but we can kind of get this test running and failing for the right reason. We'll get into that. So the player will eventually need a nav mesh agent. The enemy will need, there'll need to be a nav mesh available in this area. So we're gonna have to specify some of those things. So we're going to just generate that class in a new file. It's currently in the wrong DLL. We'll move it back out when we start using it. And we're gonna just make this a public class. It needs to be a mono behavior. Actually, we'll just see what that looks like in a second. So we've added the component. Oh yeah, can't be parameter T. It needs to be a Unity engine component, which means it's not a mono behavior. So we're going to do that first. Yep. And we already, using Unity engine would have been, the tools are being a little bit too helpful, as you can see. And so that error should go away. Now we don't have a public property target, so we will just go ahead and do that. Maybe we can just generate this, make it a field, and we're going to change that to public as well. It'll be externally settable, and the target can change often. All right, so we're kind of in a position that we can run it in the editor now and see what it does. What's really nice about this is like every time you build one of these tests, you kind of just like start seeing a little bit of flow happening, and you can kind of just, okay, this goes to that, and we're getting closer. You can see those two new game objects that happen. So we'll take a look at the error here. We expected it to be less than or equal to 50, but it was 1,000. So that's a little bit of the pain point there. What we will end up doing is we're going to go back over to the tests. We are kind of going to go and do something a little bit more simple, and show that they move, right? But first we're going to add some AI components to the system as well. So player dot add component, nav mesh agent. I think we need to use Unity engine dot AI, nav mesh agent, right? And that player is going to need to be on a nav mesh, and so we are going to need to figure out how to dynamically create a nav mesh. And we're gonna just make it as big as we can. So what we're going to do is we're gonna populate that in there. Okay, so we are going to do something pretty cool. We're gonna use some primitives to build an environment, and that will allow us to kind of finish out our test. One thing I want to change is these numbers should probably be smaller, because building nav meshes during the test is actually going to be pretty rough for us. So we got a couple of things that we need to work through, and then we'll get there. So one thing is we want our nav mesh agent to come in just before the end, after we've moved everybody. And the enemy and the player are going to have nav mesh agents. So right now, if I go back in here, this is going to cause us to just get an error that says that the nav mesh agent couldn't be found, or couldn't. There was no place to create the nav mesh agent. So we can see that right now, and you can kind of see both of the nav mesh agents because there's no nav mesh nearby. So one thing we're going to do is there's a really handy thing for unit testing and creating environments, which I never really knew about until I was trying to do unit tests. So game object has a static function on it called create primitive, and we have primitive types on it, and so we can create a plane. What that'll do is it'll give us a nice flat surface, and that flat surface can be used to create nav meshes. So one thing is we're going to scale it up to 100 times its size so that we have enough space to work with, and then we're going to build a nav mesh on it. So var surface equals environment dot add component nav mesh surface. Oh no, but you'll notice that this won't be available, and that's because this nav mesh surface is part of those nav mesh surface components that are on GitHub. And so if you watched my last video, you'll have seen that bit about assembly definitions. And so what we have here is right now our assembly definitions don't have access to those nav mesh components. So we're going to grab the nav mesh components, add them here, hit apply. And what that'll do is it'll rebuild all the DLLs, and those DLLs now will have access to those components. So as you can see, it's there now. And so we can do a runtime surface bake, or a build of the nav mesh. And that will allow us to, essentially kind of complete our test, or at least write the code that will force us to warp to the correct location, right? So, yep, make a player, make an enemy, make an environment, put a nav mesh on that environment, put a component on the player that allows the warping to happen, move the player and the enemy into the correct locations, add nav meshes to them. That will then, once this frame runs, then that'll attach them to the nav mesh and then execute the warp. And so one thing is I noticed while talking there is that our nav mesh agents need to be on our character probably before the start runs for our warp component, because I think we would set up our characters that way. So this looks pretty good to me. We should see both nav mesh agents get bound to the nav mesh, and that we're 50 units away, and then we can start writing our production code. So here we are, and we're going to go into the test runner, and we're going to run the test. And again, these play mode tests run for a really long time, but they prove that all of the different systems interact. So now we don't see the warning that the nav mesh agents have not bound to each other, and that the distance was less than or equal. It was expected to be less than or equal to 50, but was 80. So now we can kind of do the simplest thing that can work to make this happen. And so I think on our update call, we're going to just say var distance equals transform.position. Oh, no, I'll do a vector 3. vector3 dot distance transform dot position target dot transform dot position, and then maybe we'll just say target is null. We can actually drive that with a unit test. We'll do that during zombies testing. So we'll just say if distance is greater than target or max distance, then we might need to cache our nav mesh agent. So on enable, we're going to just say nav mesh agent equals get component nav mesh agents. We're going to want to grab that control dot or alt enter if you're on JetBrains tool to import that. Again, control dot create the field, and we have this nav mesh agent, and so we can kind of say nav mesh agent dot warp, and then we want to for now, I guess, until we're doing more of our zombies testing, we can kind of warp within the min distance. So maybe we can just say something like let's see, var target position equals vector, or random dot range dot inside unit circle dot normalize times min distance or target distance. And that'll give us a random location around a circle around that with that target distance. And then maybe we'll make that less than the max distance. Then we can just warp to new vector3 of, let's see, so we're going to say something like target position dot x comma 0 comma target position dot y. Why? What is on that? We might not be quite there yet because we have the x and the y. So target distance, we're gonna make that a field. It's gonna be a float. That float will be something like 45 maybe as a default. We'll eventually make those serialized fields, and then we're gonna say max distance. Max distance equals 50. So what this will do is theoretically teleport us inside of that unit circle, kind of as a happy path here. And otherwise, we're just not going to do anything. So let's give that test a shot, and that might conclude our video. And then the next video I'll do is zombies testing around this functionality so that we can flesh out some of the edge cases. Like if that value was null, for example. So, yep, test passed. And so teleported within the unit circle. So now, actually, we should be able to see this kind of functioning as long as targets are set properly. And we can bind that up on our thing that's generating our characters' enemies. So I'm gonna go down here. This spawn and circle deal does a lot of the enemy setup. Yeah, this is probably should be a number of other classes. None of this is unit tested, so there might be more episodes where I go in and unit test all of this. But what we can do in here is do something like set up warp to what is that called? Warp to target when within distance, right? And then we're going to pass it pooled mono behavior, and that's just the pooling system that I'm using. We're going to generate that method. So we'll do something along the lines of mono behavior dot game object dot add component. I'm going to add one of those in there. You'll notice that we created our class. We got to move it now. because we created it kind of in the wrong spot. So we actually want it over there anyway. So we're gonna just move this up here. We're gonna move it. Yep. And then this won't properly set up because Unity's managing the project files. So we're gonna go back over here. We're gonna let it build. And if we don't get any errors, then we can come back into VS Code and it should now recognize the new file. So we're gonna do that. We are recognized now. I'm gonna say var warp equals that. Warp.target equals, and I think we do have a reference to the player somewhere. Or the enemy target manager has a reference to the player. Player. Let's just say for now, we'll just kind of hack it to show this, and then I'll undo this code, and then we can kind of do it the right way later. So we're gonna say find object of type. Never want to do this. Player avatar. So what this will do is it'll set that object, and then we're just gonna get their transform. It'll set that up as we're generating those enemies. And then if you remember at the very beginning of the video, we had set it up, and and we'll add more functionality around this, but I want to close this video out because that kind of completed the unit test portion of this, the Unity test portion of this. As you remember, we had a bunch of guys with those red lines, and as you ran away from them, those red lines just kept growing and growing and growing. So we're going to just try and keep getting farther and farther away from these guys. You can kind of see that up here. Maybe we'll try and get a little bit closer. Oh yeah, without dying. So you can kind of see the red lines getting farther along. And so we should start seeing them teleport once they get more than 50 units away, which would be the ideal. And they're kind of coming at us as a circle. Of course, I zoomed in like too far. All right, here we go. So, and actually, maybe I'll kill off some of them to grab some of their. Oh no, I don't have. All right, well. I'm just gonna cheat maybe a little bit. Maybe not. Gotta keep going. Of course, it becomes impossible to actually show you the problem again. All right, I am going to jump up here, and we are going to like super cheat. So we got some of these scriptable objects. We got the skills, and so and of course we're gonna have to try again. But I'll give myself the sprint upgrade. Of course, testing these things in production ends up being a lot harder anyway, right? So I have the sprint upgrade, and if I pull myself out into normal mode, oh, actually, it's the sprint upgrade event. Invoke, 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 invoke. What that does is it gives me that so that I can just start running really fast. I'm just raising that a little bit more. And yeah. So just kind of running off into infinity here. And those enemies should be warped within a unit circle around me. Maybe. All right, let's see. Skeleton, grunt, skeleton swordsman. They do have it. They are trained on me. they do want to be within 50 feet of me. So, and in fact, maybe if I just highlight all of our skeletons, we should be able to see. Oh, they are warping around in the circle. So we don't have the play mode. Target position inside, random dot inside. Oh, because we needed to, in fact. So this would be why you create a unit test, because you need to actually include the target's location. So target.transform.position.x plus that target.transform.position.y plus that. And this is why you'd make asymmetric tests. And so we can kind of rewind and work out what we did wrong with the test here once we run through this. So now we should see something along the lines of getting there. So I'm going to try and cheat one more time. And maybe kill off some of these guys to grab their tasty gems so we can sprint some more. Yeah, there we go. All right, so we're going to sprint again. And yeah, now you can see that they kind of keep coming at me. So we've kind of fixed the problem. They're always... Okay, last little bit here. We're gonna make our test asymmetric so that we would have proven that this wouldn't have worked. So we're gonna go out and remove that last little bit there. And what we're gonna do is we need to make this fail with the code that passed before because it wasn't right. So if we just do everything by 80 there, and then we do 75 here, we should see a failure now because we're actually way off from the 0, 0. And so typically starting something at 0, 0 is kind of like a don't do that because you'll run into a problem. So we should be able to see that this test will then fail again. Or at least I expect it to fail. Might not. It did. Yeah, so we were 145 away from where we expected to be, even though we were teleporting. And that was because of this change. So if we go back in and re-add all this stuff in order to do the fix, then we will start we should be able to see now that we teleport near the player instead, and that removes the symmetry from our test. So yeah. So if this passes, be sure to oh, it didn't fail. It failed. It didn't pass. It didn't pass. Let's see. Our targets transform X position. Oh, because that was Y and not target Z position. So let's give that one more shot. I was gonna say if it passes, be sure to share, like, and subscribe. But maybe if this version passes, then share, like, and subscribe, and comment about what you thought about this video. This is very stream of consciousness. I'm not trying to, hide things or whatever. I'm just trying to, like, do the research, do the stuff. I do a lot of unit testing and more corporate software development. So I wanted to make sure that people knew just how easy it was to get these things done. And if you're working on a big team, you would find it. So it did pass. I'll see y'all next time.